Maybe you don't like the fact that every team has a different approach on how to connect UI with a view model. Maybe you don't like all the verbose code and the boilerplate that you need to write in order to connect them in a nice way that allows you to have a testable UI code and nice previews. Maybe you find that working with flows, when you have multiple of them, can actually get verbose and a bit unwieldy and unreadable. Or maybe you just like compose so much that you would like to write more than just UI with it. And today you're in luck, because we are going to cover the circuit that is compose first, architectural components from circuit. So this is the way it allows you to write your Android and Kotlin multi-platform and Compose multi-platform apps with Compose in both UI and presentation layer. And if you would like to, you can push it even further and use it in a business, use Compose in a business logic layer. And if you think about how that's possible, Compose is a UI library. It's not, and we are going to cover that in this video. I've been working with a circuit for a bit over 2 years. I got introduced to it by a guy named Andy that I worked on the same project with, and I fell in love with it, and every single of my personal projects afterwards, so it's like 10 projects, 4 big ones, I've written with Circuit, and I absolutely love it, and I will continue to use it. Let's jump into what it is and how it operates. So the premise of a circuit is that you have two main components. There is a UI and there is a presenter that is connected via some screen. So this screen is used to connect the two. It's just a glue, and it's how you're passing data around. When it comes to the actual UI and presenter, how things work is that state flows downwards from the presenter to the UI, and events flow in one way from UI to presenter. It's a unidirectional data flow. It's beautifully done and executed. It uses multiple libraries to make this concise and possible. It uses Molecule for creating flows with Compose. We will see how to do that. It's a total mind shift, but it's way less code. It's a pleasure to work with, and if you love Compose, you're going to enjoy it very, very much. And now let's first see our problem statement, what we are trying to solve, what is that boilerplate that I'm talking about, and how Circuit eliminates most of that, all of that, and how it will help us minimize that glue code and just focus on writing what we need, and it does everything for us. But first, let's address how Compose is not just a UI library and how it works in a presentation logic, and even you can put it in a business logic. So Compose is a general purpose node management and state management library that's split into multiple parts. The most important and notable ones are runtime. This is where all the machinery of the Compose lives in. I recently gave 2 hours presentation on this on JetBrains sponsored meetup in Belgrade. So if you guys would like to hear more about this, I can record it for the YouTube channel too. And there is compiler plugin, and this is the core of Compose. As you can, and this doesn't have anything to do with UI, though those two are actually connected. The compiler is teaching the runtime how to work with your code and how to use it, but UI is on the totally different side of the fence, and that is a separate library within Compose ecosystem. So you have UI, then you have, for example, material, then you have foundations for all the foundational components, and we can arrange them like this. And let's just align it for my OCD. The UI and everything related to the UI is on this side, but pure Compose is on this side. It doesn't have anything to do with the UI. It's very nice for the UI management and management of UI trees, and those are connected, but they are on the different side of the fence, as you can see. And this is why it is perfectly fine to use it in a presentation layer for presentation logic to create flows in You can even do it in a view model without circuit presenters, but it's even fine to use it in your domain for your domain logic and data layer, if you will. And let's see the problem statement that we are working with. I have some very basic structure here, so you don't watch me type that much. But this is a classic counter example. So as you can see, we have a count state, and we have the UI that accepts the view model and then collects the count and then represents it. If you would want to test this, you would need to provide a fake view model for UI tests or even for previews. If you want to avoid that, then you need another UI component that looks something like this, that's not taking view model as this one is, but is taking count that we are collecting here, and we will do this. So we will call that new component that will show the UI, and now we can have our previews that are easy to write. And if we see how that works, we have that one. But if we want to have a preview for this one, then we would need to have view model, then we need to pass it to a problem statement UI view model here, and when it comes to actually testing the UI, it's even more ugly, even more verbose, and we did not even introduce events handling. For example, what you can do, there are so many approaches to do this, but you can have fun increment and decrement, and then it would be count update it minus -1. It's not minus, it's not mutable. And then it would be count.update it +1. No, it's actually reverse. It's actually reversed. So you can either do this, or you can have some events declared. Sealed interface event data. We can have object because we don't need any to pass any data. Increment, decrement, and you can see that we are going off screen just for this trivial example. And then you can have I would not do this in it. I don't like creation side effects. I would have function called in it, but this is just an example. And then of course we need some event sync. The most popular example floating around is to have it with channels, so let's just do that, because this is considered, the current state of the most popular thing. So we have events, we can receive as flow, collect, no, not count, collect, and then when it, and yes, we need view model scope, launch, then this, and then add remaining branches. I like to import those just to have cleaner thing. And then we would have count update. So this is, I want to have increment first, but yeah, it's -1. Then we would have count.update it +1. And let's rename this, let's call it event. And as you can see, we already need to scroll to see this, but it is such a trivial example. Of course, you will not have everything in the same file, but you see how verbose it is. We need to launch this, to collect this, we need to update the state here, and then we need some, for example, fun on event of type event, and then it would do events.send, or you can do try send if you don't want it to be suspend, and we would send that event. It returns boolean, so we can have it as an expression function, but this is something that you would generally have, and then you would add callbacks into our UI, but I think that you will already get to the point. And you would have callbacks sent here, And this is already just for this simple example of a non-trivial statement. Everything is loosely coupled, so you don't have to have this problem statement UI connected with the problem statement view model, but you probably want those two to be connected. You don't have concise way of doing this, and to showing previews and UI tests. And with the latest screenshot UI testing, this becomes even more valuable to have easy way to create previews. So as you can see, a lot of verbose code, and we did not even add events, sending of events, but it's also trivial, but adds code to the example. And let's see how we can solve this with the circuit. For that, we need to add dependencies. So the most important one is of course circuit, and then for easier use and creation of the screens, etc., you would need some dependency injection framework. I just chose Metro here because it is the new kid in the block, and it's very nice. It's very nice. A dependency injection library. It's a compiler plugin, so it runs. It's fast. It doesn't generate code, but Circuit works with Hilton Pure Android, works with Kotlin Inject, works with Metro, so you can works with Dagger. So you can choose whatever you want, and we will see how we can utilize this. But you need circuit, and then we have all the circuit dependencies here. For now, you don't need these gestures, effects, overlays, tests. We will cover that in another video. So we don't need code gen also. I will show you that in another video, but for now you just need the foundational ones. You add them. It's pretty standard way of adding things. Just add them as dependencies like this, and then let's start writing our circuit solution to this problem. So I've mentioned before that we had that screen that connects the presenter and the UI. That is the first thing that we need to create, and for now we can have that as an object. So circuit solution screen, and it should extend this screen. Those are just marker interfaces to allow a circuit to connect things. Then you would have circuit solution presenter. Sorry, before going there, we need some state and events for the screen. We will define a state. We will do the same counter example. So it would be count, and it would need to extend circuit UI state, and then we would have sealed interface event, same data object, increment and decrement things. Okay, then we would need to extend the presenter, and it would extend the state that we have, and we will override. So this is the only thing that presenter needs to override. It's a composable function called present, and I will just add this import here, and it would need to return some state. I mentioned that it is the compose first and compose all the way, all the way down. So we are using compose even to create flows. This is using Molecule under the hood. You can check out the library, it's amazing. You can even use it with plain view models. It's just nicely integrated into Circuit. And you would work with this as you would with the normal compose. It's third earthquake today. Let's hope that I can finish this video by the time everything collapses on me. You would write code that's plain simple compose code, but it will emit state flow. It will emit flow of the type state, and you will have var count by remember mutable state of 0, if I can type, remember, yes, and then you would do return state and count. Okay, we can remove this. But what about events? This is one of my most this is one thing that I like the most about Circuit. It blew my mind when I saw it. It's so simple, but it's still one of my favorite, features. This is really a feature. It's the way of doing things, but I love it. It's event sync. That it is just a plain function that you pass into state and you pass event into it. And if we go down here, then here we get the event, and then we can handle that event. Well, event remaining branches, and it would be count minus minus. Here it would be count plus plus. As I said, I like to import these kind of things just to make everything more readable. You can even extract this as a separate variable inside of this present function, Port Earthquake. Okay, and that's how you create a presenter. And you can see that this is replacing your state flow. This that we had two, mutable one and mutable state flow, regular state flow. We had event sync. Now we just have one callback function that will be called from the UI. We'll see that just in a second, and you can see how much concise this already is. Then we would have circuit solution UI, and yeah, let's accept the modifier, and it also needs to accept the state. We need to represent the state, right? And here we can have scaffold with column. Modifier, always use the modifier provided by the circuit, and it will be provided by the circuit. You will see how in just a second. And modifier padding it, and then we would have text state dot count to string spacer modifier. Okay. Then we would have a row of buttons, horizontal arrangement dot space bar 16 dp. We can do that here also. Vertical arrangement space by 16 dp. Button on click. We'll just have that in a second, and it will be text increment, and then we would have another one with decrement. And what we will do on the on click, it would be state event sync increment. We just call like regular callback function. It's very slick, and I love it. And we have decrement. And right now, if we actually run this, we cannot, because we don't have any, we did not create any way to actually bridge the things. How will presenter know that it should be connected to this UI, etc. This is where factories come in, and in the next video I will show you how we can leverage circuits code generation to make this even smoother, and everything that we will write now will be replaced by a single line of code. But for now we need to have a factory, and it would be presenter factory. Here is where we create our presenter, and we will check for screens, add else branch null, because we don't care about other screens. We care just about our circuit solution screen, and for that one we will return circuit solution presenter. We don't care about the rest. As you can see, we have navigator here and the actual screen. If we would have some data to pass, then we would have some data class and val data, for example. And then if you would like to inject that into the presenter, you would need to define screen here and then just pass it from here, and inside of a presenter you can access that data and use it however you'd like. We don't want to do that right now. We will have more involved examples, but same with the navigator. You would want to navigate on certain events, you would pass the navigator the same way. And actually I just noticed that contributes into set, we will need this. This is just a metro thing. You would do this for every single one, and we need inject here. Actually we will need to reuse this. So this is the factory for our presenter, and then we will have the factory for our UI. Also class circuit solution UI factory, it would extend UI factory, implement members, create, the same thing as before. We don't care about other screens. We would just for the circuit solution UI, we just care about circuit solution UI screen, and we will do when screen add else branch, it would be null, and then circuit solution screen, we would return the UI. This is how you create it, and then it would be circuit solution UI, and then pass state and modifier. It's complaining. Oh yes, we need to define the state that it would need to pass. Yeah, so it needs to know what this state actually is. Okay, now we have factories. It knows how to connect things, and this is not actually the end of our setup, because we need to set up the dependency injection. This is how you would have your component, or in the case of Metro, the graph that will expose the circuit. Then we provided a multi-binding with this. We provided those into set, and also on line 57 we have that for the presenter factory, and all of those would be collected here. Circuit would be built. This is all the code that you need to write manually, but and that's all of the code that you actually need. Now we actually want our app to present the screen that we have, and as you can see, it is in common main, just the app, the general, like you would normally have the app. And circuit also handles navigation and backstack, so you will need a navigator and the backstack. Remember, savable backstack, and this is where you define the initial screen. For now we have only one screen, and that will be our circuit solution screen. Remember navigator, and it needs a backstack, and it needs en route pop, but we don't need to implement that right now. And now we will connect everything and show it in the actual UI. You need circuit composition locals, that is the glue between that allows circuit to connect things and inject what it needs, etc. And because we have navigation, we would need navigatable content that takes in a navigator, backstack, and it takes decoration factory. And just 1 second, let's separate names, and then it needs this decoration factory for gesture navigation on platforms. Okay, and with this we are done. If we were to add more screens, we don't need to change anything here. That is different from, for example, navigation 3. Every time you add a new screen, you will need to go back to where you defined your nav graph. You will need to define a composable related to that navigation entry. You will need to set navigation to it and from it, etc. But no, this is, we are done with this right now. Not disable. I wanted to show you how this is the Metro way of injecting things into the activity. This is not a Metro tutorial. I just want to glaze over it and show you the circuit features. So you may not choose Metro as dependency injection framework. You would maybe do content inject. That's also a great solution, and it would be slightly different, but the principles are the same. And you will just call the app and you would pass circuit to it. We can run the app now. Or we cannot. I will show you this in just a second. You need this hack for multi-platform apps, but you don't need it for Android. So we have increment, we have decrement, and that's it. We can make this a bit prettier. Horizontal alignment, center horizontally. Run. As you can see, works. The thing with common parcelable, so every screen needs to extend parcelable, and it actually does on the Android side, but you don't have the same things on the multi-platform side, and you need to define. This is just how I chose to name it. It's common parcelable. It is something that we define, as you can see in the File Explorer tree. That lives inside this code base. It's a custom annotation. And I put a little comment here that is for Android parcelable, and you need to connect it somehow. And this is how you do it. You are looping over the targets that you have defined for your multi-platform app. You are looking specifically for Android JVM, and for that one you just want to apply this to add this common parcelable thing, and that's it. You don't need to define anything in Android module, etc. As you can see, this is empty. Here we just have the app, circuit, etc. And that's it. In the next one, we will see how all of those factories that we have, for example, this one will be replaced just by a single line of code, and the circuit will be able to handle more things, even more things for us. Also, this would be resolved by a single line of code, and then you would have just the code that you would want to write. You would not have any glue code, you would not have any boilerplate, you would have anything. You would just have plain presenters, you would have plain UI, and everything else would be handled for you. Connecting those, navigating between those, creating, connecting, everything. If you like this video, leave a like and subscribe, and see you in the next one.